Hello guys, welcome to the online student. Today we're going to be looking at L'Hospital's rule. I'm going to explain to you when you can use this rule, how to use this rule, and then we're going to make some exercises where I will explain the process step by step. We're going to solve these 4 exercises. Okay, let's have a look at when to use L'Hospital's rule. L'Hospital's rule can be used when a limit as x approaches c for a certain fraction is either 0 to 0 or infinity to infinity, a so-called indeterminacy. If this is the case, the limit can be found by taking the limit of the derivative of the nominator divided by the derivative of the denominator. But there are a few conditions. The conditions are the following. Firstly, the limit as x approaches c from the nominator has to be equal to the limit as x approaches c from the denominator and has to be either 0 or infinity, positive or negative. Secondly, the nominator and the denominator have to be differentiable in this point c. Lastly, the derivative of the denominator may not be equal to 0. You might be wondering, or just may have forgotten, when is a function differentiable? Well, the function is differentiable in point c if the derivative of this function in point c exists. This means that the limit as x approaches c of the derivative of the function coming from the left, and this is indicated with the minus sign here, is equal to the limit as x approaches c of the derivative of the function from the right, and this is indicated by the plus sign. So let's say we have this red function. In point c, the limit of the derivative coming from the left is positive. You can see this is a positive slope, so the derivative will be positive. However, the limit of the derivative of the function coming from the right is negative. You can see the slope is negative, so the derivative will be negative as well. And thus the left limit is not equal to the right limit, and so the function is not differentiable in point c. Generally, we could say that kinks or cusps are not differentiable. Okay, let's have a look at this first exercise. We need to solve this limit as x approaches 3 of 27 minus x to the third power divided by 2x squared minus 11x plus 15. First of all, let's check if we get an indeterminacy so we can use L'Hospital's rule. We fill in the value 3 for x. This gives us 27 minus 27 divided by 18 minus 33 plus 15, which comes down to 0 to 0. So we can use L'Hospital's rule. We'll call the nominator the green function and the denominator the red function. Okay, now we're going to apply L'Hospital's rule. This H symbol indicates that we use L'Hospital's rule. That means that we take the limit as x approaches 3, but we take the derivative of the nominator, the green function, and we divide it by the derivative of the denominator, the red function. The derivative of the nominator is minus 3x squared. The derivative of the red function is 2 times 2x minus 11. If we simplify this, we get the limit as x approaches 3 of minus 3x squared divided by 4x minus 11. All we have to do now is just fill in the value 3 for x. This gives us minus 27 divided by 12 minus 11. Which comes down to minus 27 divided by 1, which is of course equal to minus 27. And so we found the solution for the first exercise. Okay, let's have a look at this next exercise. We have to solve this limit as x approaches infinity of 2x to the third power plus x squared plus 1 divided by 3x to the fourth power plus 2x. First of all, let's check if filling in infinity for x gives us an undefined fraction. Alright, so if we fill in infinity, and as we can see, if we simplify it, we get a fraction of infinity divided by infinity. So we can use L'Hospital's rule. We'll call the nominator the green function again and the denominator the red function again. We'll start off by applying L'Hospital's rule. So we take the derivative of the nominator and we divide it by the derivative of the denominator. The derivative of the denominator is equal to 2 times 3x squared plus 2x plus 1. The derivative of the denominator is equal to 3 times 4x to the third power plus 2. We simplify this so we can get rid of these parentheses. This gives us 6x squared plus 2x plus 1 divided by 12x to the third power plus 2. Now we can fill in infinity for x. If we fill in infinity for x, we see that we still get a fraction of infinity divided by infinity. This means that we can apply L'Hospital's rule again. So we again take the derivative of the denominator, which is 6 times 2x plus 2, and we divide it by the derivative of the denominator, which is 12 times 3x squared. We once again simplify this so we can get rid of these parentheses, which is 12x plus 2 divided by 36x squared. Now we can fill in infinity again, and we see that we still get an fraction of infinity divided by infinity. So we once again apply L'Hospital's rule. We take the derivative of the denominator, this gives us 12, and we divide it by the derivative of the denominator, which is 36 times 2x. We simplify this and we get the limit as x approaches infinity of 12 divided by 72x. Now we once again fill in infinity for x. This gives us 12 divided by 27 times infinity, which is infinity. So we get 12 divided by infinity, which is 0. And 0 is the solution to this exercise. This exercise is a great example of a certain rule of thumb you can use. But this works only for a limit as x approaches infinity. In this example, you could apply it. Let's say we have the original fraction of the second exercise. We could eliminate everything but the term with the highest power of x. This would give us the limit as x approaches infinity of 2x to the third power divided by 3x to the fourth power. If we simplify this, we can get rid of this x to the third power, so we get the limit as x approaching infinity of 2 divided by 3x, and then we can fill in infinity for x, so we get 2 divided by 3 times infinity, which is also equal to 0. Reminder, you can only use this if x approaches infinity. Let's continue and have a look at this third exercise. We have to find the limit as x approaches infinity of x times the arctan of 1 divided by x. First of all, we check if we need to use L'Hospital's rule by substituting infinity for x. This gives us infinity times the arctan of 1 divided by infinity, which is equal to infinity, times 0, which is undefined. Now, we could transform this function to make it a fraction, right? We take this x and we write it as if it were 1 divided by x, which is mathematically the same as just x. But now we have a fraction that we could use, that we could apply L'Hospital's rule to. We'll call the denominator the green function and the denominator the red function again. Let's substitute infinity for x so we can check if we need to use L'Hospital's rule. This gives us arctan of 1 divided by infinity divided by 1 divided by infinity. We know that 1 divided by infinity is 0, so we have the arctan of 0 divided by 0, which comes down to 0 to 0, so we can use L'Hospital's rule. The derivative of arctan of 1 divided by x is this bad boy right here, minus 1 divided by x squared divided by 1 plus minus 1 divided by x squared. The derivative of the red function, 1 divided by x, is quite easy. It's minus 1 divided by x squared. This term right here, minus 1 divided by x squared, we have in the numerator and the denominator, so we can eliminate it. Then we have the limit as x approaching infinity of 1 divided by 1 plus 1 divided by x squared. Now we can fill in infinity for x, so we have 1 divided by 1 plus 1 divided by infinity squared. This is 0. So we have 1 divided by 1 plus 0, which is of course 1. Let's have a look at this fourth and last exercise. We need to solve the limit as x approaches minus infinity of x to the power of n multiplied with e to the power of x. Let's see if we need to use L'Hospital's rule. So we fill in minus infinity for x. This gives us minus infinity to the power of n times e to the power of minus infinity. This is equal to positive or negative infinity times 0. This is equal to 0. We know that this is undefined. So we could transform this function again so that we have a fraction. So we can apply L'Hospital's rule. We could write this e to the power of x as if it were 1 divided by e to the power of minus x. So now we have a fraction that we can apply L'Hospital's rule to. We call the denominator the green function again and the denominator the red function again. Let's check if we can apply L'Hospital's rule. We fill in the value minus infinity for x. This gives us minus infinity to the power of n divided by e to the power of minus times minus infinity. This gives us a fraction of infinity divided by infinity, so we can use L'Hospital's rule. We take the derivative of the denominator, which is n times x to the power of n minus 1, and we divide it by the derivative of the denominator, which is minus e to the power of minus x. We fill in infinity for x, and we get n times minus infinity to the power of n minus 1 divided by e to the power of minus times minus infinity. And we see that we still get a fraction of infinity divided by infinity. So we apply L'Hospital's rule again. The derivative of the denominator is n times n minus 1 times x to the power of n minus 2. The derivative of the denominator is e to the power of minus x. If we fill in minus infinity for x, we still get a fraction of infinity to infinity. So we could use L'Hospital's rule again. The derivative of the denominator is now n times n minus 1 times n minus 2 times x to the power of n minus 3. Derivative of the denominator is minus e to the power of minus x. If we now fill in minus infinity, we still get a fraction of infinity divided by infinity. Here's a quick reminder of what factorial is. If you multiply 1 with 2, with 3, with 4, and we continue until we multiply it with n minus 2, multiply it with n minus 1, and finally we multiply it with n, this gives us n factorial. Here's a few exercises of what factorial means. For example, 4 factorial is the same as 1 times 2 times 3 times 4, which is equal to 24. Let's go back to our initial fraction. We know that we can apply L'Hospital's rule because we checked it. Let's say we apply L'Hospital's rule the first time. We take the derivative of the denominator and we divide it by the derivative of the denominator. Now, we could use L'Hospital's rule again, and we once again take the derivative of denominator and denominator, and we get this like we did. Now, if we do this again, we get this one. Now, you can see where I'm going, right? If we keep on applying L'Hospital's rule, we eventually get n factorial for the denominator. Now, the derivative of the denominator, which is basically always the same, except this minus sign changes. Here is it minus, here is plus, here is minus again. So we eventually get the limit as x approaches minus infinity for n factorial divided by either positive or negative e to the power of minus x. Now we can fill in minus infinity, which gives us n factorial divided by positive or negative e to the power of minus times minus infinity. Now, if we simplify this, we still get n factorial divided by positive or negative infinity, which in both cases is equal to 0. And this is the solution to the fourth exercise. Alright, thank you for watching. If you have any questions, leave them in the comment section below and we will reply to them. If this helped you in any way or you enjoyed it, please consider to give us a like and subscribe. And we'll see you in the next video.